When I need to complete the square to find the vertex of a quadratic when my a is not equal to 1, I like to apply the factoring approach. Basically what the factoring approach is going to allow me to do is get rid of this 4 so I can now complete the square. So what I'm going to do is I'm going to group the first two terms. Then I'm going to just factor out the 4. I don't need to factor out 4x because we're not trying to factor out the GCF. I'm just trying to get rid of this 4. All right, so now what I need to do is create a perfect square trinomial. I have my coefficient of my x squared inside the parentheses is equal to 1. So I need to find the value that creates this perfect square trinomial. That value is going to be c. c is equal to a b divided by 2 quantity squared. But it's really important when you factor out this 4, not only do you factor out the 4 from the first term, you also have to factor out the 4 from the second term. It's a very common mistake that students will make, and I'll even make it right now. So now, there's a reason why that's important is because 2 is going to be your b. So make sure you factor out both terms. So 2 divided by 2 is going to be 1. 1 squared is equal to 1. This is the value that creates my perfect square trinomial. I need to make sure I'm going to add it inside this parentheses. But to keep this equation balanced, if I add it on one side, I either have to add it on the other side, or I have to subtract it on the same side. In this factoring technique, I like to add and subtract it on the same side. Now, you might be asking, where did this 1 come from? It's really important to understand. I added a 1 inside the parentheses, but I'm really not adding a 1 on this side of the equation because via the distributive property, this 1 is being multiplied by 4. So therefore, if I subtract the 1, which I did, I also need to make sure it's multiplied by 4. Now, the next step is really important that a lot of students still struggle with, but I think once you get the routine of it, you start to see it's not that bad. This is a perfect square trinomial, meaning it can be factored down into a binomial squared, meaning the same binomial multiplied by itself. So when we're looking to factor this, what I'm looking for is a factor or a number that multiplies by itself to give you 1, but then adds to give you 2. Hopefully you understand that's going to be 1. So therefore this binomial is going to be an x plus 1 squared, or x plus 1 times x plus 1. -3 minus 4 is going to be a -7. Now I have completed the square to put my quadratic in vertex form, and I can identify the vertex as a -1, -7.